LCL. Everybody should know how to read mixing ratio. What is the difference between mixing ratio versus saturation mixing ratio?
One's temperature, one's dew point.
Which is which?
Mixing ratio, dew point, saturation, mixing ratio, temperature.
Mixing ratio follows the dew point. Saturation mixing ratio follows the temperature. Make sure you do not confuse those two.
Mixing ratio follows dew point?
Yes. So anytime you hear mixing ratio, you should automatically think dew point line. Anytime you hear saturation mixing ratio, you should always think temperature line. Let's see. How many grams of water have been condensed? I think we pretty much already got that. So compute the lifted index. So lifted index. Again, you're going to find your LCL. Raise your parcel up to 500 millibars. Doing just what we've already done. Let's see, the Li is the 500 millibar temperature of the surroundings minus the 500 millibar temperature determined for the parcel. So remember, it's whatever your temperature line is at 500 minus the temperature of the parcel that you just calculated, or that you just rose up to 500 millibars. Right?
Could you say that again?
So let's say we had some sort of profile in here. I don't know, maybe we brought something like that. Here's your temperature at 500 millibars. What is your Li for that profile?
Minus that temperature minus the
What is the
temperature.
actual? What is the number?
Minus 6. I can't read.
The temperature surrounding is 5, minus temperature parcel, minus 5. 5 minus a negative 5 is what? 10. Make sure you don't get tripped up on that. The double negative becomes positive. Is that stable or unstable? Why stable? It's a positive number. Remember with Li, anytime you have a positive number, you're looking at stable sounding. Anytime you have a negative number, it's unstable. Right?
I'm sorry, could you repeat that?
Positive LIs are stable, negative LIs are unstable. Everybody understand how to get this lifted index? What's your LCL?
890. Oh no, 780.
750.
Right, about 790, roughly, just below 800. How do I find lifted index?
Raising the log voice, adding that 500.
Yep. And let's say, here's your 500 temperature. What's your Li?
Temperature of surrounding air minus the
Which gives you
Yeah.
minus 20, minus 10.
-10.
Negative 10. Stable or unstable?
Unstable.
Unstable. Very unstable. An Li at minus 10 almost screams explosive convective development.
Okay, so
Yeah, you want
Can you-
anything below minus 6 is usually pretty good.
put that in bigger size. I can't see the numbers from here at all.
Look at your lab 12.
Scott, what size note card?
5 by 7.
Can you make it a little bigger or like?
Yeah, by 11.
That's already the biggest one out there.
Oh, I can find bigger.
24 by 36.
It's all about size.
Bring a scroll.
The easiest thing to remember when you're dealing with LIs, and this is a good thing to remember for the test. test. If the temperature of your parcel is to the right of your ambient temperature, it's always going to be unstable. If it's to the left, it'll always be stable. That way, you'll know which way you're assigned to be, whether your number's going to be negative or positive.
Can you repeat that?
This is your ambient temperature reading right here at 500. If once you've risen your parcel up to 500 millibars, if it's warmer than your 500 millibar temperatures, it's always going to be unstable. It should always be a negative number when you're calculating LI. If, however, your ambient temperature is on the right-hand side, over here, then this will always be a positive number, and this will always be stable. So there's a trick, you can check your math. Just by knowing that, you should know if you should get a negative number or a positive number. All right?
Are you putting the formulas down on the tests? Those are what we need to know. Okay.
Yes, so for the test, you need to know how to find the lipid index, the K index, and the total total index. Then I will tell you that the chart for totals total, you do not need to know for the test. I will put that on the test form.
Oh.
Yeah.
That'll save you some room on your index card. And see,
How long is this gonna take though?
2 hours.
2 hours?
2 hours. Everybody usually finishes.
You, or you just hate me?
I know.
It's my way of revenge for the semester.
What have you done?
It's not that bad.
We can't take like part of it home.
You want me to?
You get to take this
I
guy
don't
home.
even know how to find any of this.
Scott, you know if you do take home finals, you get more time for yourself to, you know, do
Right.
other stuff.
Yeah.
And you learn more.
You can check out that triple lane no love.
Yes. That'll be the day. K index. Let's see, this one is fairly straightforward. Temperature at 850 minus temperature at 500 plus the dew point temperature at 850 minus the dew point depression at 700. What is the dew point depression? Difference between your temperature and your dew point. So,
That's right.
I'll put that in the test. Remember what dew point depression is. Don't forget that. It's just the difference between your temperature and your dew point.
So if you average the 70,
At 700.
75, you do.
On this one, it's 700, yes. The dew point depression at 900 should just be the difference between temperature and dew point at 900. So it's always at the same level. Let's see. All temperatures and dew points are in Celsius. I'll be nice and I won't give you guys anything in Fahrenheit. Totals total, again, temperature at 850 plus the temperature of the dew point at 850 minus 2 times the temperature at 550. So make sure you write those 3 equations out. Sorry?
Okay.
The LI, the K, and the T.
Yes.
But the LI is not a formula.
It's not a formula, but know how to figure it out.
Oh, yeah, I'm lost.
Enough.
There are no calculators allowed in the final, just so you know.
How
This
many-
is all fairly straightforward arithmetic. I would hope that any of you at this point in your life should be able to do